Welcome back at C Squared. In this lesson we're going to talk about perpendicular bisectors and also about perpendicular bisector for triangles and what comes with that. First of all, let's take a look. A perpendicular bisector is a line, a segment, or a ray that pass through the midpoint of a segment and is perpendicular on that segment. There you go. This is what we call a perpendicular bisector. This line L cuts the segment AB in half. We can see these two segments are congruent and is perpendicular here. There are two theorems. Let's see the first one, the perpendicular bisector theorem, which says if a point is on the perpendicular bisector of a segment, then the point is equidistant from the endpoints of the segment. Let's take a look to this picture. Okay, this point P is on the perpendicular bisector. We notice these two segments are congruent. This angle is 90 degrees. So PT is the perpendicular bisector. Therefore, is equidistant from the endpoints. So that means PA and PB are congruent. The second theorem is the converse, which says if a point is equidistant from the endpoints of a segment, then the point is on the perpendicular bisector of the segment. Hopefully this picture will tell us how that works. We notice PA and PB are congruent. Point P is equidistant from A and B. That means this gentleman, this point is on this perpendicular bisector. The line that cuts AB in half, and it is perpendicular on AB. So we're going to use this theorem for the next example. And in the first example, we need to find each measure, justify your answer. That is important, why we say what we say. And we notice here on part A, we have AD, which cuts BC in half. These two segments are congruent and is also perpendicular. So we can say about AD is a perpendicular bisector. Okay, so let me be sure. I'm going to say segment AD. So which means point A is equidistant from the endpoints. A equidistant from B and C. This is the justification, and now the answer is very simple. AC should be 5, right? Because these two segments are congruent. Let's take a look to part B, which is very similar. If you notice, we have what? We have HF. That is a perpendicular bisector. Why? We notice these two segments they have the same measure, so they are congruent. The right angle is right here, so that means point H is equidistant from E and this other point, which is G in fact. So I can use the same theorem, the perpendicular bisector theorem, and say, hey, AG should be congruent with HE because point H is equidistant from these endpoints. So HG equals HE. So HEG will be nothing else than 7. Okay, let's take a look to the second example. And in this one, we need to find the value of X and Y. And again, we need to justify our answer. So what do you see on part A? We notice these two segments are congruent, which means point D is equidistant from A and C, because we notice those two segments are congruent. And we notice also a right angle here, so that means BD is perpendicular bisector. So, which means then these two segments are congruent, and that will be my equation. So, the first part I just justify why I can write this equation. Very important in geometry to justify your work. And here I will subtract 6x, and I'll get here 15 equals 4x minus 25. I'll add 25 here. So I have here 40 equals 4x. And if 40 equals 4x, the last step will be to divide by 4. And we have x equals 10. And that is the first part A. Let's take a look to B. B, I think, is very similar. We notice these two segments are congruent. This is a right angle, so obviously HF is the perpendicular bisector. So this point H is equidistant from E and G. So I'm gonna write here HE congruent. Let me mark them in the picture also with HG, because point H is equidistant from the endpoints. So HE equals HG, so which means 18y minus 7 equals 16y plus 23. This is the algebra of this problem. And like I said, the geometry is the fact that we have a perpendicular bisector in the picture. I'm going to subtract 16y here. So 18y minus 16y is 2y, minus 7 equals 23, add 7, and we have 2y equals 30, divide by 2, y equals 15. But again, it's very important in this problem to understand why you can write this equation, the reasoning. In my next problem, we're gonna look a little bit to perpendicular bisector on a rectangular grid. And I said here, you will have to find the equation of the perpendicular bisector. Yes, of course, because we are on a rectangular grid. Find the equation in the slope-intercept form of the perpendicular bisector of AB. If A is 1 and 3, you see it here, and B is 5 and 5. So this one, first of all, you want to find the midpoint of AB Why? Because if you remember, the perpendicular bisector goes through that point, the midpoint of the segment. So the formula for the midpoint is xm equals x1 plus x2 over 2. In this case, x1 is 1, x2 is 5. So we have 1 plus 5 divide by 2, that will be 6 over 2, and that will be 3. Very similar, we're going to do the y coordinate of the midpoint, which is y1 plus y2 over 2, that will be 3 plus 5 in this case, right? Because this is y1, this is y2. And that will be 3 plus 5, like I said, divide by 2, that will be 8 over 2, and that will be 4. So the midpoint is at 3 and 4, and you may say, I can see that in the picture, this is the midpoint. Yeah, we can see sometime the midpoint, we can eyeball it because it's simple. So that is the first step, but then my next step will be to find the slope of the perpendicular bisector. How do you do that? How are we going to find the slope of the perpendicular bisector? Remember, the perpendicular bisector is perpendicular on AB. So I'm going to find the slope of AB. And in this case, since I have the picture, I'm going to use the picture, or you can use the slope formula if you want. We notice the rise is 2, the run is 4. So 2 over 4, it goes up from left to right, so it stayed positive, so that would be 1/2. For those who want to use the slope formula, I'm going to put it here. You can use it, y2 minus y1 over x2 minus x1. You will get the same value of 1/2. So now I'm going to flip this guy. I'm going to make it 2 over 1. And I'm going to change the sign, negative 2 over 1. And eventually simplify negative 2. We can do that. Alright. This negative 2 is the slope of, I'm going to call it L, of the perpendicular bisector, this guy. And we have the point M that belongs to that perpendicular bisector. So we have two choices, the slope-intercept form or the point-slope form. I'm going to use the point-slope form. Y minus y1 equals m times x minus x1. And we have here y minus, now y1 is this 4, now, equals m, this is the m, we did it, negative 2, x minus x1, this is this 3. This is the point slope form of the equation of the perpendicular bisector. We're going to have to do the distributive property here. So I'm going to move here. So we have y minus 4 equals negative 2x plus 6. And the last step is to add 4. And we get y equals negative 2x plus 10. This is the equation of the perpendicular bisector, and let me show you graphically. From this point M we can draw a line with slope of negative 2. That means you go 2 down, 1 right. I can do that pattern one more time, and I can go 2 up, 1 left. This will be a negative slope, right? Let me try to draw that perpendicular bisector L, something like this. In fact, you can see a better picture here, right? So that's what we did algebraically. We were able to get the equation of the line L, which is the perpendicular bisector of segment AB. Okay. Let's move to the next part of the lesson. In this next part, we're going to talk about what's happened if we have a triangle. And a triangle, as you know, it has 3 sides, so obviously it's going to have 3 perpendicular bisectors. You see that these 3 lines here, L, M, and N, I'll call them like that. They all are intersecting in one point. We call them concurrent lines. And that point of concurrency is very important. It's equidistant, very key word in this lesson, and not only, from the vertices of the triangle. Look at here what I meant. This point D is equidistant from A, B, and C. This means these 3 segments are congruent. And also, this is called a circumcenter, by the way. And we call that a circumcenter because you can draw a circle like this one around the triangle, put the compass in this point, you have the radius, one of these segments, and you can draw the circle. This is called a circumcircle, you see it here. And these segments I mentioned before are called circumradii, in case you need that vocabulary. So now let's see these cases. Whenever you have an acute triangle like this one, like the one we just discussed, the circumcenter is inside of the triangle. However, if the triangle is obtuse. You notice this angle here is more than 90 degrees, so triangle ABC is obtuse. The circumcenter is outside of the circle. And you notice also we have a nice circle around this obtuse triangle. And we have this special case. Yes, we have a right triangle. We can see that here. In this case, the circumcenter is right here on the longer side of that triangle. The hypotenuse, I said here, is the midpoint of the hypotenuse. Yes, these two segments are congruent. Moreover, this one is congruent with the other two. This is a very special case, good to remember in geometry. Now let's see some problem here. We have this triangle, point D is the circumcenter, so probably I should have this right angle here to show that thing. Okay, and we know BD, this segment here is 12, DE is 5, okay, and we need to find CE, this segment right here. So the first thing I want to say is that CE is congruent with VBY because AE is the perpendicular bisector. We notice D is the circumcenter. Okay, so I'm going to write that here, CE congruent with BE. So if I want to find CE, maybe I can find BE then, and that will be simpler then, because CE, the measure of CE is the same with the measure of BE. And if you notice, we have this triangle right here, DEB. I'm going to draw it right here. And this one is a right triangle. We know this DB, I mark it, is 12, and DE is 5. We need to find this BE, which is, I will call it X, right? So one more time, this is D, this is E, and this is B. Well, we have a theorem that will help us to do that, which is what? A squared plus B squared equals C squared, Pythagorean theorem. Now be careful because this X now is a leg. So we're gonna have 5 squared plus X squared equals 12 squared. So that will be 25 plus X squared equals 144. We're going to subtract 25 on both sides to solve for X squared. And the last step, we're going to take square root of 119, and that will be how much BE is, because that's what we call X, right? So now square root of 119. Let me grab a calculator. And that would be 10.9 rounded to the nearest tenth. So BE is 10.9. So CE, the one we're looking for, should be the same thing. Okay. So let's take a look to the next example, very similar. Point D is the circumcenter of triangle ABC. So probably I should have again right angles here. Apologize for that. Now we know it's the circumcenter. Find the value of X and the length of BD. If AD, this gentleman here, is 4 times the quantity X plus 3, and CD is equal to 7 times, so this is CD, the quantity 2x minus 14. And you notice I mark the same, these two gentlemen. Why? Because this point D is equidistant from the vertices. Oh, so you tell me this one is going to be the same. Yes. So let me write that here. The circumcenter Okay, therefore AD, AD not AB, will be congruent with DC and congruent with BD. Okay, that's the property of the circumcenter. So now we can use this first part of the statement and say, hey, AD, and I'm sorry I said here BC, it's BD. BD. So we can say AD equals with DC or CD, either way will be good. So now we have the equation that probably some people will start with: 4 times the quantity x plus 3 equals 7 times the quantity 2x minus 14. So we have to solve this equation to find the x. But again, the justification is very important in geometry. So we have here 4x plus 12 equal 14x minus, and let me grab a calculator, 7 times 14, that will be 98. So now I will subtract 4x here to get rid of the x's on the left side, and I have 12 equals 10x minus 98. I'm gonna add 98 on both sides, and I have here 110, I believe. Let me be sure. Yeah, 110 equals 10x divided by 10, and we have x equals 10. Oh, that was the first part to find the value of x. Okay, so now we can move to the next part to find the length of BD. So we can find any of these segments, either AD or CD. AD is 4 times the quantity x, so x is 10, plus 3. So we have 4 times 13, and that will be 52. How much AD is, and BD should be the same because these two segments are congruent, they have the same measure. Why? Because point D is the circumcenter of triangle ABC. My next problem, we have point E is the circumcenter of triangle ABC. So we notice we have EF perpendicular on AC, EG perpendicular on BC. So I can put something like that here. These segments are congruent because point E is the circumcenter. And also, I guess I can say these segments are congruent because those are the radii of the circumcircle. And it says find the value of x if AE is 2x plus 1, BC is 48, and EG is 7. So we notice this is 7, and we also know BC is 48, because BC is 48. We can find BG, for example. BG will be half of 48. That will be 24. Because remember, E is the circumcenter, so EG is part of that perpendicular bisector. It cuts BC in half. So both of these are 24. And now we have this triangle here that will allow us to find BE. So we have this triangle. Let me try to kind of match it, at least as orientation. This is 24, this is 7 point G, right angle here, E here, and B here. So now we need to find this BE, I will call it X. So again, what we can use here is Pythagorean theorem, a squared plus b squared equals c squared. Now this, what we have here are the legs, so we just plug it in. 24 squared plus 7 squared equals c squared, or x squared like I call it in the picture. So 24 squared is 576. 7 squared is 49 equals x squared. 576 plus 49, that will be 625 equals x squared. So x will be square root of 625, which will be just 25. In fact, it's good if you remember this Pythagorean triple, 7, 24, and 25. That is a good one to remember sometime, like in this case. So this x is nothing else than segment BE. Okay, so we did find the value of x which were asked. And now we can, in fact, this x is different than our x, so let's be sure. Let's stay with c here just to not to get confused. Okay, so because this is not the x we need. C, 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 C. The x we have goes with AE. AE is 2x plus 1. And if you remember, I said AE and BE are congruent. These two segments are congruent because E is the circumcenter and is equidistant from the vertices. So AE is equal with BE. So now we can write this equation here, 2x plus 1, how much AE is, equals 25. I'm going to subtract 1 here, 1 from the other side. We have 2x equals 24, and divide by 2x. This is the x we're looking for, 12, just to be sure we do not mix with the other x, I call it first on the right triangle. So this is the value of x for this problem. In my last part of the lesson, I'm gonna look to find the coordinates of the circumcenter in a rectangular grid. And on this first problem we have this triangle DEF. You notice the 3 points, D 3 and 1, E 3 and -5, and F 7 and -3. We need to find the coordinates of the circumcenter. I will suggest you, if possible, draw the triangle. Why? Sometimes that is easy. Look at here what I meant. I'm gonna look first to this segment DE, and the midpoint of that segment is right here. It's easy to see it. 1, 2, 3, 1, 2, 3. And since this is a vertical segment, I can draw a horizontal segment, this dash guy, dash line, let me call it L. This is the perpendicular bisector. Why? It's perpendicular and cuts this in half. So just by doing this, I know this circumcenter should be somewhere right here. It has an x coordinate of 2. Now, let's take a look to the other two segments, and maybe we are lucky, maybe we are not. But let's take a look. The midpoint for this DF is right here. So I think I can see the pattern here. Okay. Oops, unfortunately this is not the perpendicular bisector, this is something else, my fault. Okay, and the other one is right here. Okay, so can we draw the perpendicular bisector for any of these? And if you take a look, the slope of DE is 1, negative 1, so I think the slope of the perpendicular bisector should be 1. So we have this point, this point, this point. We have multiple points. We don't need all this. But look at here how simple this problem is graphically. If you have this choice, do it. Because we finished the problem and we didn't do too much math, too much algebra, which sometimes can be dangerous, right? This is the circumcenter. Let me call it point, not D. Let me call it point R, right? Okay, so R is located at 4 and 2. And we found that point graphically. One more time. Midpoint, use the fact the slope of the perpendicular bisector are negative reciprocal of the segments you have, and maybe you can get that circumcenter. I'm gonna have a disclaimer. I think that doesn't work on this example. On this example, I'm gonna have to do some work probably, but I'm gonna try to see if graphically works. So we have the triangle. We can eyeball this midpoint here. We can see the slope here. It's positive 1, so we're gonna get to a negative 1 here. This is the perpendicular bisector. And you notice I did multiple points. It's gonna help me on the screen to draw this perpendicular bisector. So I know now my circumcenter should be right here. Let's see if I'm lucky and get a second perpendicular bisector that will give me the intersection point. Okay, so now I'm looking to BC, and I think is this the midpoint? I think so. Let me go back. Sorry. This is the midpoint. And this one, if you notice, the slope is negative 3/2, so I'm gonna have to do positive 2/3, so 1 point will be here and 1 point will be here, and I think that's all I can do. But again, you notice we are not lucky in this case. We can get an estimation. Is that sometimes good? Yeah, if you have a multiple choice, yeah, why not? So the circumcenter is somewhere here. Okay, but let's find it. And now let's do a little bit of algebra. And we're gonna start with segment AB. What is the slope of the segment AB? And if you remember, I said it's positive 1. Now, if you take a look, we can draw this triangle, count 1, 2, 3, 4. 1, 2, 3, 4. 4 over 4, positive, because it's going up, so it is 1. So now my first thing to do is to write the slope of this line L. The slope of that line L will be what? We're gonna flip this guy 1 over 1, change the sign, and simplify, so we get that negative 1. Yeah, that's the slope of this line L, if you remember when I drew it. Okay, and the point, this point here, I can use it. What I have here is 0 and 3, which is good, because right now I have the equation of that line, y equals negative 1x, or just x, plus 3. This is a very important equation. It's the equation of line L. And now let's move to the next line. The next line is, let me change the color, and I guess I'm going to use this pink. This line, let me call it T, where we need to find the slope of this segment BC. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. BC has a slope of going up 6, left 4, negative 6 over 4, or negative 3 halves. Now let's flip it. Negative 2/3. Let's change the sign. Positive 2/3. That will be the line T. The slope of line T will be 2 over 3. And now we need this point. We can use the picture, why not? And that will be 4 and 2. We are not lucky with, like the other one. We have to write an equation, y minus y1, which is 2 equals m 2/3 x minus x1. 4. Okay, now we have these two equations. This one and this one, right? So how do we have to handle to find the intersection point? It's like a system of equation, right? These two intersect in this point. So what can you use here? I think the best way is to use substitution. We're gonna take this y and replace this y. So I'm gonna have, and I'm gonna move right here, and I'm gonna have negative x plus 3 minus 2. So again, that negative x plus 3 is this y here, which was replaced by this expression, equals 2 over 3 times x minus 4. And you know what? I think the best way to handle this is to multiply by 3. Change the color here. And in fact, the first thing, let's do it, this first thing. Let's simplify the left side. Negative x plus 1 equals 2 over 3 x minus 4. And like I said, I personally will multiply by 3 to get rid of that ugly fraction. Of course, there are more than one way. So let's see what we get. We get negative 3x here, right? Distributive property, plus 3 equals, and now these two guys cancel out, and we have 2 times x, which is 2x, and 2 times 4, it's 8 minus 8. Okay, so we didn't go that bad, it was pretty good. I will add 3x here, and that will give us positive 3 equals 5x minus 8, add 8. And we have here what? 11 equals 5x. So let me move right here. 5x equals 11. Divide by 5. And we have the x. The x is 11 over 5. Does it look like 2 something? Yeah, 11 over 5 here. How do I find y? You can plug it in any of those equations we start from. So I will plug it here. So let me be sure this is the x coordinate of the circumcenter. And let's find the y, and that would be negative x, negative 11 over 5 plus 3. Okay, so probably the best way to handle this is to change that 3 in. What divide by 5? It's 3, that will be 15. And that will give us y equals 4 over 5, or kind of a 0.8. Does it look like? I think so. Okay, 4 over 5. This is the circumcenter, if you wanna call it, let's say D is located 11 over 5 and 4 over 5. Yeah, in this problem you really have to do some work to find the circumcenter. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.